9-4, 0 and negative exponents. So far we have worked with positive exponents, so we know that 2 to the third power means to take that base of a 2 and multiply it by itself 3 times. So what does a negative exponent mean? Well, whenever you've got a negative exponent like that, what it does is it changes sides of the fraction bar. So this actually turns into 1 over 2 to the third power. Whenever it doesn't have a fraction bar at all, that means it's at the top. So that's why it moved down to the bottom of a fraction bar and it became a positive 3. So that is what's going on here. And today you're also going to learn that anything raised to the 0 power equals 1. Now I'm going to record a separate video that explains where these rules came from, just in case you want to know. Okay. All right, so that looks kind of weird, but here's all that it's basically going to do. If I've got a fraction bar and I've got a to the negative 2 on the top, all I need to do is take that base and that exponent and change the side of the fraction bar that it's on. It's on the top now, so I would move it to the bottom, and once I've moved it, well then it becomes a positive exponent. So our whole goal here is to get rid of the negatives and the 0 exponents. So the same thing, if you've got a negative exponent on the bottom of your fraction, you're going to move it to the other side, so in this case the top, and then it would become a positive 5 for your exponent. So that is the basic idea of what is happening today. Let's go ahead and look at example number 1. Okay, anything raised to the 0 power, I don't care what your number is. Let's get rid of that negative, that comma. But if you raise something to the 0 power, it equals 1. I don't care what it is. It always equals 1. Okay? So when I have a to the 0 power, that just equals 1. Now for example 2, I've got 12y to the 0 power, and a lot of people are very tempted to tell me that the answer is 1 on that. But remember, exponents only apply to the number or letter that they're touching. So that 0 exponent only applies to the y. So that means that that y to the 0 actually does equal 1. So I'm going to replace it. Okay. And if I multiply, well, 12 times 1, that just gives me 12. So a big idea for the exponents is that whenever it's only one letter or one number raised to the 0 power, it just equals 1. But if you've got something with a 0 exponent in the middle of a bunch of other things, basically all you have to do is cross it out, because 12 times 1 still just equals 12. So multiplying by 1 doesn't change it, so that's why we pretty much just cross them out. So let's take a look down at example number 3. Now I'm going to rewrite this so that you have a better idea of what this problem started looking like. So I have 5a to the 0, b to the negative 2, c to the negative 3, d to the 6th. Okay, not every single one of those pieces is going to move. Now, first thing that I notice about this problem is that I have a to the 0 power. So I'm going to go ahead and mark that out. I don't put an a over here because if you just write the letter a, that means there's an imaginary 1 for the exponent. So it is completely gone because it equals 1. And if I multiply 5 times 1, well, that's still just 5, so that's why it goes away. Now that 5 does not have a negative exponent or anything, so it is going to stay on the top of the fraction bar where it already was. Okay? But the b that's on the top part of our fraction has a negative exponent, so it is going to have to move. So that b to the negative 2 power changes sides. It's on the top right now, so I'm going to move it to the bottom, and then it becomes a positive 2 once you have moved it. So that one moved. Okay, I've got a negative exponent attached to that c. So that means that that one is also going to move. So if I've got c to the negative 3 on the bottom, I'm going to move it up to the top, and it becomes c to the positive 3. It changed sides of the fraction bar, and then it became positive. Now the last term that we've got there is d to the 6th power. That one already has a positive exponent, so it does not move. It stays where it was. It's on the bottom of the fraction, so I'm going to put it back there, and I'm finished. So today you're going to know your problems are simplified whenever you do not have 0 or negative exponents. All right, example number 4. Okay, same idea, so I'm going to go ahead and put my fraction bar right next to it. We're going to take this one piece at a time, so I'm just looking across the top. That 2 does not have an exponent, okay? It doesn't move with the a or anything like that. It's its own little piece. So that 2 is going to stay up on the top where it already was. But I've got a -3 for the exponent attached to my a value, so that guy is going to move. If it's on the top of the fraction right now, it moves down to the bottom and then it becomes positive. Now, b squared is already on the top and it's already positive, so it's going to stay on the top like that. So b squared is still up there. Okay, now I'm done with the top. Let's move down to the bottom. Okay, on the bottom, I've got c to the 3rd power. It's already got a positive exponent, so it is going to stay. It's on the bottom of the fraction bar, so it stays on the bottom of the fraction bar. And then I've got one more piece, d to the -5 power. That one has a negative exponent, so it is going to move. It's negative on the bottom part of our fraction right now, so we're going to change it and move it up, and then it becomes d to the +5 power. And there's our answer. Number 5. All right. I'm going to put my big set of parentheses right here, or sorry, my big fraction bar. Okay. Big mistake on this one. A lot of people are very, very tempted to move the -3 down to the bottom and change it to a +3. But guys, the -3 does not change sides of the fraction bar because it's not an exponent. All these rules that we've been learning apply to exponents, not to the big numbers, the coefficients. So that number stays where it is. So I'm going to fill in my answer here. Does the -3 need to change sides of the fraction bar? No, because it is not an exponent, so it does not move. Okay. So I'm going to keep the -3 on the top where it already was. Now, x to the 3rd power is next. That one's already got a positive exponent, so it's going to stay where it is. It's on the top, so it's going to stay on the top. And then I've got a y value. I have y to the -2 power. Since it's got a negative exponent, that guy is going to move. If it's on the top right now, it moves down to the bottom, and it becomes a +2 exponent. Now that z to the 0 power on the bottom is gone. I'm just going to get rid of it because it equals 1. And taking something and dividing it by 1 doesn't change it. So this is my answer. Okay, so that's the basic idea, and what we're going to be talking about on the back here is the strange cases, the little things that can kind of get you on this assignment. So I'm going to go ahead, do the same thing for each one of these. I'm going to go ahead and put my fraction bar on this problem, and I'm not going to keep writing the stay and move stuff. I see that I've got x to the -1 power on the top, so I'm going to move it down to the bottom, and then it's a +1 exponent. Okay, so I'm done with that guy. I can put a check just if I want to. Now that 4 doesn't have an exponent, so it's going to stay on the bottom where it was. Now I put it in front because the big numbers, the coefficients, always need to be in front. Okay, a to the 0 power equals 1, so I'm going to mark it out. I don't need to put an a down. And y to the 5th power was already positive, so I've got to keep it where it is. Now, when you don't have something left on the top part of your fraction, you have to put a 1. And whenever you only have a 1 on the top, this is the case where you have to keep it. But the best answer is 1 divided by 4x y to the 5th power. Mathematicians are kind of lazy, and if they don't want to write a 1, they're not going to. So that's why this is better to write it just as x instead of x to the 1st power. Okay. Now, number 7, we've got a negative exponent, but we don't have a fraction. So what we are going to do is the same trick that we learned whenever we were doing slope. If you don't have a fraction and you need that guy to be a fraction, we'll put a 1 on the bottom, okay? That's all that's happening. Here's my new fraction bar. That means that this b to the -8 is on the top, so I'm going to move it down to the bottom. Now, this 1 doesn't have an exponent or anything. It's still there. okay? And then I don't have anything remaining on the top anymore. That's when I have to put a 1. Okay. Now, the only time that you have to keep a 1 in your problem is if it's alone on the top part of your fraction. So I do have to keep that 1, but I don't have to keep the other. So the most simplified answer is 1 over b to the 8th power. Number 8. Once again, I've got a problem that's not a fraction, so I've got 3y to the negative 2 power. I need to change it into a fraction, so I'm going to put a 1 on the bottom. That way I can see which side is which. Now be very, very careful. I'm going to write this one more time. That number, the 3, is going to stay because the exponent is not applying to the 3. It stays on the top where it was. But it's the y value that's got to change sides, so it's going to move. So I've got y to the negative 2 power, which means y squared on the bottom. Now this 1 is here, so you can put it there if you want to, but you don't have to because it's not necessary. You only have to keep the 1s when they're alone on the top part of your fraction. Number 9. Okay, so I've got my fraction bar right here. I'm going to go ahead and put my new fraction bar in. That 1 on the top still is there. It doesn't move. I've got x to the negative 10th power on the bottom, so I'm going to move it up to the top part of the fraction, and now it's positive. Now, when you don't have anything remaining on the bottom, you can put a 1. But remember, 1s only have to stay if they're alone on the top part of the fraction. So that means I don't need any of those 1s. My answer is just x to the 10th power. Let's get practice with one more of those. So I'm going to go ahead and put in my fraction bar. The 2 is going to stay where it was, but I've got k to the negative 4 on the bottom of my fraction. I'm going to change the side of the fraction bar that's on, and then it becomes a positive 4. If I don't have anything on the bottom, I can put a 1, but the only time you have to keep 1s is when they're alone on the top part of your fraction. So this one is 2k to the 4th power.